foci, all of that's still the same. C squared is going to be found by doing a squared plus b squared. That hasn't changed. The only thing we're adding into this, guys, is the h and the k. I will remind you that you'll notice sometimes when it is a y squared hyperbola, obviously the y value comes first. Be careful when you write out your ordered pairs for your center. It's not going to be k and h. You have to make sure you flip it, h and k. All right? And I'll show you an example of that here in a second. So just like from there's two there. That's fine. So we're going to go through the process again. The only thing that's going to be a little bit weird is writing the equation of the line of the slant asymptotes. That's just the last little bit, because now instead of it going through the center, the origin, it's going to go through the h and the k. And then it's still walking through our slope. So we're going to use point slope form to write the equation out, and then solve for y. All right? Let's just jump to an example. Let's do this one. We'll do this one first. How many of you guys aren't here on Friday? I hear there's a lot of people out.
When was Friday?
The day after Thursday. I just knew there's a couple of field trips and stuff going on. Okay. What I think we'll wind up doing is we'll test out of this stuff Thursday, so we don't have to wait anything on Monday, and we'll just build back in 10.7 later on. It's not a big deal if we don't hit it right now, to be honest with you. Okay. We might actually we might go into a little bit on Wednesday. It doesn't take long. So in this case here, first thing I'm going to do is identify my h and k. What's my h and k? 3, so my center is at 3 and 2. A squared value, 25. B squared is 9. C squared is 4.
Wow, that's just
What direction is this going? Yeah.
I went to Shakir's class to get my stuff, and I told him I was going back to Murph Dog's room, and he actually wrote Murph Dog. Just thought you should know.
Left and right. It's x squared, so it's got to go left and right. If your a squared is 25, what's your a?
5.
Plus or minus 5. B is plus or minus 3. And C is going to be plus or minus 34. Let's see. I don't believe anything works with 34, does it?
No.
Nope. So it's plus or minus root 34. What's that? Absolutely. Let's say it was the square root of 20. That's 4 and 5, so you get 2 root 5. Just so happens it's one we think we can. All right. So I have my center at 3 and 2. I know it's got to go left and right. A value was 5. Vertex is 5 away from that spot, which means I move it left and right 5. So if I'm moving it left and right from the vertex, what am I adding to the? Which one am I adding to for the as far as the center is concerned? The x or the y value? X. So my vertex is going to be at 8 and 2 and negative 2 and 2. Add and subtract 5 from the x coordinate. Covertex, I'm adding and subtracting to the y coordinate now, and I'm adding and subtracting 3. So we get 3, 5, and 3, negative 1. I now have my 4 points that I connect the rectangle for. Because what goes through the diagonals? The asymptotes. The slope of the asymptotes, that's easy because all you had to do was go up 1, 2, 3, and we went over 5. So the slope was 3/5 or negative 3/5. But the equation isn't going to be just 3/5 x in this case because it's not centered at the origin. It's been moved. So that's where we're going to use that point slope form. Okay? Thank you. So when we use our point slope form, remember that's y minus y sub 1 is your slope, x minus f sub 1. And we're going to use the center at 3 and 2, so your x and y values there will be 3 and 2. I know we haven't done the focus yet, we'll come back and do that in a second. So we have y minus, what was it, 2? It's 3/5 x minus 3. Y minus 2. So you get y minus 2 equals 3/5 x minus 9/5, which means I have to add 2. Instead of adding 2, can I add 10 over 5? Means the same thing, doesn't it? So what's negative 9 plus 10? 1. So one of my equations would be y equals, so 3/5 x plus a fifth. And then I do the same thing with the negative slope. So we have y minus 2, negative 3/5 x plus 9/5. Subtract over to get y equals. So those wind up being my two equations of my asymptotes. Sir?
We get the x minus 3 and x plus 9/5.
I'm using the center as my, for a point slope form. I'm substituting it in here, and then I'm just distributing. Distribute the negative 3/5, that's where I get negative 3/5 x plus 9/5. When I distribute here, I had 3/5 x minus 9/5 because it's positive negatives. Yeah, sure, keep.
What did you add? 10 over?
Oh, thank you. I looked at the wrong sign. Thanks, Shimky. Sorry, guys. Well, when I add the 2 over, I looked at the wrong sign. Sorry. So I'm adding 10/5, so it becomes 19. That's okay. And remember, your calculator actually has the fraction button on there, so you can actually do it in your calculator if you don't want to.
Oh, that's so cute.
The moose in his Ninja Turtle pajamas.
Is that a soccer game?
Yeah. No. It was a football game, I think. It was a couple weeks ago. No offense to soccer. I'm not anti-soccer.
It's not soccer.
What was it, 9/5? No offense, I'm sorry. Do you guys play soccer?
Did the Cubs win last night? I didn't get a chance to watch the game.
It was 9/5 plus 2. If you put it in your calculator, if you put it, guys, if you put it in your calculator with the fraction bar, it'll spit it out with the fraction bar. So you should never get these little, I mean, the fractions for a lot of these asymptote parts, they're going to be nasty. They just wind up being that. So just use your calculator. Don't mess it up. Okay? And then the last part there, we have to put in our foci. Our foci was the C value from the center. We said it was the square root of 34. Square root of 34 is just about 6. So we just have to go past here, because this would be 6 for the next one, so it's just before it. So when I write that out, what did I add the foci to? The x value or the y value of the center? X. So my foci will be at 3 plus root 34, comma 2, and 3 minus the square root of 34, oops, comma 2. Now your favorite part in the whole wide world, drawing a curve.
Yay!
Hug the asymptote is right. Hug the asymptote, go through the vertex, and hug the other asymptote. Hug the asymptote, go through the vertex, and hug the other asymptote.
Yay.
It's not that difficult, it just takes a little while. It really does. The shifted ones just take a while to
That's why you only give the dice off.
probably right. Okay. Two slopes. We had one of them that was, shh, guys, we had one slope that went up and right, the other one went up and left. So one's positive, one's negative. Yeah.
Wait, why does the focus go there? You say it's like around the slopes. Wouldn't it be like the inside?
No, it's on the outside because this value here was 5,
Oh.
and it's just a little bit more because it's almost. I should have rephrased it. It's almost 6.
Okay.
Okay. All right, let's do another version of it. Let's write the equation given the information and see how this works.
Oh, man. Cooper is just so, his like responses are so honest.
So we have foci at 5, 2, 5, negative 6. And we have vertices at 5, 0, and 5, negative 4.
My V's are ugly.
Just by looking at that, you can probably tell what direction this is going to go. Very good. And it's got to go up and down. Why? The x's stay the same. That's what I was looking for. All the x values are staying the same. So what we're going to do here is kind of plot it. Guys, please stop talking. We're going to plot it so we get an idea of where things are being placed. And then we can find our center easily.
Yay, math.
So 5, negative 6, 5 and 2. Those are my foci. Vertices at 5, 0, 5, negative 4. So I know it has to do this. It always opens to the foci. Vertex is always looking at the focus. The center is always, no matter which conic we're looking at, the center is always going to be the midpoint of a focus, the midpoint of a vertex, the midpoint of a covertex. Every single time. It has to be. Yes, ma'am? Or write the equation. Right now I know that it is up and down, which means which one's going to come first, x squared or y squared? Y squared. All we did by plotting that is to get the idea of which direction it's going to go, so then I know to use the y squared version of the hyperbola. And now I'm going to fill in the blanks. Yep. So I'm going to find the midpoint of the vertex. What's 0 plus negative 4? What's half of that? So I know my center is going to be located at 5, negative 2. There's my h, and there's my k. My a squared value is going to be found by the distance, well, a value from the center to the vertex. How far is negative 2 from 0? 2. So a is 2, therefore a squared is 4. I don't have the b squared value, but I do have the c value. The distance from the center to the focus is 4, so the c value is 4. So c squared is 16, which means 16 equals 4 plus what? 12. So there's my b squared. Do I have everything now to fill in the blanks?
Yes.
Here's the point where you have to be careful. Notice that it's a y squared parabola, so that means it's going to be y minus k. Don't put in y minus 5, and x plus 2. That's what you guys will screw up, because you'll see this is the first order pair, but it's k then h in this case. Careful with that part. So we wind up with y plus 2 quantity squared over 4 minus x minus 5 quantity squared over 12. There's 1. And I know we've done a ton of these problems throughout the whole thing by just getting centered and stuff. Hopefully by now it's not so bad. Just like completing the square is probably not so bad by now, right?
Yeah.
Because what do you think we're going to do next?
Oh no.
No. So let's complete the square.
Yay!
Because tomorrow, you guys are going to have a whole bunch of problems that just look like this, and you're going to have to figure out which one it is. Yeah. And every single one of these problems starts the same. Actually, you know what? What's the easiest conic to figure out? Why? Right. Guys, remember, the easiest conic to figure out is going to be the parabola, because it only has one of the squared terms. In this case, it's pretty obvious that it's forcing you to see it as a hyperbola. Why do you think that is? Well, it's 2 squares, but then it could be a circle or an ellipse or a hyperbola. Why do you think I'm leaning this towards a hyperbola besides the fact it's the hyperbola section? So did ellipses and things like that as well. It's minus. See how the x squared term has a negative 9 in front of it? Since that has the negative term in front of it, it's got to be up and down because the y squared comes first because you're going to subtract the x squared. That's the trick. When you notice when you have hyperbolas, when you go to reorder this, put the positive one first. Okay? Put the positive one first because that's going to force you into the generic form of the hyperbola being one term minus another term. Since I have the y squared one first, we know that this is going to have to open up and down. Just right away, I know it's got to go up and down. So we have to complete the square. What's the first rule of completing the square? Make sure the coefficient's 1. So here, I'm going to take out the 16. And I get y squared plus 4y plus blank. What do I take out of the next part? The negative 9. Very good. Take out the negative 9, which means you have to change the sign of the 54. So you have x squared minus 6x plus blank equals 161. And what do I have to put in on the other side? Plus 16 blank
Plus blank. Oh yeah, that's
minus 9 blank. Remember, you have to take, whatever you take out, you got to put back in. If I took out the negative 9, I got to put in negative 9 times something. If I took out a positive 16, I got to put back in a positive 16 times something. Okay. Now the easy part. What's half of 4?
2.
So I have 16 y plus 2. When I square 2, what do I get? So I put 4's in, minus the 9. What's half of negative 6? Square negative 3, and you get? 9. So now we have 161 minus 81 plus 64. 144. Convenient, isn't it? Remember, if and when you see these things on a test, you start getting really, really awful non-square root style values, you've probably done goofed. Try again. Don't get me wrong, you can still get some weird numbers every once in a while, but a lot of times you get something pseudo-clean. Okay? So divide out by the 144. Oh, this is nice. It's a lot of the same numbers over and over and over again. They try not to really make you super mad. Shall we graph and do all the fun stuff now? What's your H and K? 3, -2. Good. Want to make sure you guys didn't actually say -2 and 3. This is going to be 3, -2 because it's this winds up being probably the easiest one in the world to do. So take a minute and finish it. Don't forget to write the equations for the asymptotes. When we do take the test and stuff on, love trig. Trig is awesome.
You're right.
Which is really sad.
Yeah. I always forget the plus or minus.
It's got to go up and down because the y squared came first.
Wait, what are you doing? No, I did it all day.
Well, just cut your paper, retape it back in.
That's what I do.
The fact that I do that.
Center to vertex is 3, so 1, 2, 3.
I'm gonna
We're
cry.
at 3, 1. And it'll be at 3, -5. Co-vertex, going left and right 4. So we'll be at 7, -2, -1, -2. Make the rectangle. Asymptotes.
I messed it up.
Focus goes up 5, down 5, so we went up 3, so we have 4, 5. So that's at what? 3, 3, 3, -7. Only thing I'm left to do is write my equations. I went up 1, 2, 3, and I went up over 4, so my slopes are 3/4 and -3/4. It is 3, right? Yeah, because we went up 3 to the vertex and went over 4 to the co-vertex. My ordered pair for the center was at 3 and -2. So we have y minus, y plus 2 is 3/4 x minus 3. Y plus 2 equals -3/4 x minus 3. So I have 3/4 x minus 17/4 for one of them. And then the other one, -3/4 x plus 9/4 minus 8/4, so we get Do I need to draw the curve? Can you kind of go through the curve? I should make this official. Hug the asymptote, do-si-do, where it stops, nobody knows. Ah! That was awesome!
That was really funny.
No, it's not.
That's the math team slogan. Hug your asymptote, do-si-do, where it stops, nobody knows.
No.
No, well, it's
Everybody knows what's
Yes, ma'am.
Scroll down.
It's gonna give you a hug. Okay?
You're welcome.
Why not?
Wait, so what time do you do the
Guys, hold on.
When you do the negative one, you're supposed to switch to X. Or like the
No, it's still the same ordered pair. It's still going through the same ordered pair. I just distribute out so I get a positive 9/4 instead of the negative 9/4 because with the signs. That's all. It is positive because it's negative. The ordered pair is 3, -2, so it's y minus -2, so it's y plus 2. And then it's x minus 3 for the other one. You don't change the ordered pairs at all with that. All you're changing is just the slope. One of those will be positive and negative. Okay. Let me give you a couple of these to do for tonight. I've got 2 of them that are just what's the equation, and 3 of them that are to do all this. Okay.
Hey.
Mr. Murphy, how do I graph a circle in
What's that?
How do I graph a circle in the calculator?
You really can't?
Mr. Murphy,
nice.
5 questions.
He just said that.
What's the date today?
Mr.
Mr. 19. Thanks.
Today is the 19th. Tomorrow, you guys are going to have well, you have the whole class period. I'm going to be in a meeting basically all day tomorrow. I'm really looking forward to it. The problems I have for you guys tomorrow are just everything's given to you in that like descending order style. You're going to have to figure out what conic it is to label out focus, vertex, co-vertex, all that fun stuff. So it's a lot of completing the square. Yes, sir?
Will we be allowed to work in groups?
Absolutely. As long as you don't annoy yourself, you'll be fine. Wednesday, what we're going to do is kind of tie everything back together. We will think of what you're getting tomorrow is kind of like your review stuff. There was one more section that I was hoping to be able to get to, but since I'm going to be gone tomorrow and with third hour, I'm missing like a dozen people out of third hour, and with a handful of you guys here on Friday, it's just going to be easier just to move the test part to be on Thursday.
Yes.
Then to be on Thursday. But then on Friday, we'll do the intersection of the conics. So then when we do that into the next unit, I'll probably just throw one question on a quiz about it, and then we'll call it a day. Intersection of conics is solving systems of conics. You're just going to graph and see where they wind up running into each other, or basically using a lot of algebra. It's fun.
Yeah.
JC, trust me. You know you want to figure out where an ellipse and a hyperbola run into each other. I can see it in your eyes. Yes, sir.
So could you graph a circle
Nice.
could you graph a circle if you solve for y?
You can, but then you got to do plus minus.
Oh yeah, you're right.
It works.
How do I do a plus minus though? Like just plus and then minus?
You do 2 separate functions. One of the square root functions positive, one square root function's negative.
Okay. All right, thank you.
Yes, the shift
Yeah,
and the
because I was trying. I like my friend draws pictures on the calculator graph. I was trying to figure out how to do it, and like I'm understanding. I'm like trying to figure
what
out how to
happens
make
if you do
circles,
that?
and, like, type in circles through.
Hey guys, let's say you had square root. Let's see, x squared. Would that be x squared? No, I'm thinking this wrong here. Sorry. Yeah, x squared minus 4. Wrong button. Oh, there's a plus in there. Yes, so it's got to be maybe x squared plus.
I mean, you might as well try.